In today's video, we're going to be taking a look at how I've integrated my Texecom Burglar alarm system with my self-hosted smart home system. I've already shown this alarm system in a couple of videos. I made a video when I first installed it, and I made a video more recently where I replaced the wireless keypad with a wired keypad. But what we'll now do is talk about how I've made the system smart. This is a Texecom Premier Elite burglar alarm, and it's not a smart alarm in any way. Nowadays you get a lot of smart alarms, Ring, all those kind of things. I didn't want any of that. This is a proper, conventional, high-end burglar alarm. So this has no network functionality, no apps, no cloud connection, nothing. You set it up on the system and it's fully self-contained. And in my mind, this is a much better way of doing a burglar alarm, because a system like this you're going to install and keep it running for many, many years. You don't want something to treat it like an IoT product that you're going to need to rip out and replace constantly as manufacturers change and stop supporting devices. A perfect example of this was a company called Boundary, who made a smart alarm system a couple of years ago. They heavily promoted it through a lot of influencers on YouTube, and about a year later, they went out of business. And anyone that bought that system is basically stuck with a useless system because it required an app to set up. This alarm doesn't require that. However, I would quite like to integrate this alarm with my smart home system. I want to use this for a couple of different reasons. First of all, I also want to get messages when the alarm goes off. I want to find out that the alarm is activated. I also want to use the alarm to control different aspects of my smart home. For example, when I go away from home and arm the alarm system, I want to turn off my heating and turn on my cameras, because I have some indoor cameras which I want operational when I'm away from home, but I don't want them recording when I'm at home. So what we'll be doing is we'll be connecting this alarm to the network, connecting it into my smart home system, and using it to control the heating and the cameras. As I mentioned, this is a completely dumb alarm system, but that's not to say that it can't ever be smart. The way that Texecom design their alarms is very clever. The alarm panel itself doesn't contain any smart functionality. Instead, any smart or communication functionality is added on through external modules. So they sell modules for lots of different things. You get modules that are essentially just basic modems that connect to a phone line, that connect to an alarm receiving center. They do GSM modules that connect to a mobile network. They do speech dialers that you can connect in that will phone a phone number and play a pre-recorded message. And they do IP modules. They do 3 different modules connected to a network. The main one that they offer that's sort of advertised at the moment is the SmartCom. This is an external box that we mount to the side of the panel, connect to the inside of the panel, and connects to the network over Wi-Fi or Ethernet. This, however, is a cloud-based solution. If you want a cloud-based solution, it's a great idea. It connects into your alarm panel. You can use a Texecom app. You can monitor the alarm. You can remotely set it. You can remotely unset it. You can do a bunch of different stuff with it. It works pretty well. However, this isn't really what I want, because at least last time I checked, this didn't support any kind of API, so I wouldn't be able to use it to pull the data into my own Node-RED-based smart home system. The other 2 modules they sell are a bit more usable. These are the COM IP and the COM Wi-Fi. These connect to the serial ports inside this panel we'll take a look at in a minute, and essentially all these do is just connect that serial port onto the network, and you can telnet into it basically. There's 2 different models of these. The COM Wi-Fi is obviously Wi-Fi, and the COM IP uses an Ethernet connection. However, these are quite expensive, about £100 if not more, so we'll talk about a sort of alternative I've come up with that should be a little bit cheaper. What we'll do before we do that is we'll pop the front off the panel, take a look inside and see how it's laid out, then we'll take a look at the hardware we'll be using. Okay, so we're now inside the panel. Unfortunately, I can't fit myself in the cupboard along with the camera, so I'm going to have to sort of gesture with a screwdriver, so I apologise for that. But here we have it. So you've got the main PCB in the middle, battery, power supply over there, bunch of connections on the bottom for wired zones, the external siren, which is wireless in my case, the wired keypad, which is there, all this kind of stuff. But the 2 ports we really care about are these 2 white COM ports. So this one here and the one below it. These 2 ports here. And these are COM ports. And essentially all these are wired TTL serial ports with a 5-volt logic level. And they also have a 12-volt output. And these are designed to connect external communicator modules. So if you want to connect a modem that connects a phone line, or you want to connect the COM IP or COM Wi-Fi modules, this is where you connect them. And what's really cool with these ports is they don't have a protocol that's set in stone. The system has a bunch of different protocols available that you can configure, and once configured, that COM port will speak that protocol. We'll talk about the protocols later and look in more detail, but in my case here, the one protocol we'll be using is the Crestron protocol. This is designed for integration with Crestron smart home systems, which is a big high-end vendor of super posh smart home system for multi-million-pound houses. But the protocol is actually very easy to understand. There's decent sort of documentation online for it. I think some people have kind of reverse engineered it or whatever, but it's relatively easy to understand, and we can easily use it to get the alarm status, view the alarm being triggered, and even send key presses to the keypad to essentially control the alarm, which is really good. However, what I also want to be able to do is configure this alarm system over Wintex, which is Texecom's Windows software. This is also possible, so you can either connect a USB cable into, connect a USB to TTL serial adapter into one of these COM ports and plug it into a laptop. Texecom sell a special cable called a PC COM, but it is literally just a USB TTL serial cable with a different connector on the end. You can connect that in and use Wintex. However, I'd rather connect this over the network because it saves me taking the front off the panel if I want to configure it. But this is also something that they support. With their PC COM module, you can plug it into one of these COM ports, connect to the panel over from Wintex over the network, and configure the panel remotely. So I also want to be able to do that with my setup here. However, what I've found from some testing is I can't really use the Crestron protocol and connect over Wintex on the same COM port. I think if the Crestron protocol is completely silent and not sending any messages, then Wintex will happily connect over the same COM port as it. But as soon as Crestron starts sending out messages, you move through the house and trigger a zone or something, that starts breaking the connection to Wintex. So with my setup here, I'm wanting to connect both of these COM ports onto the network, one to be used for connection from Wintex, and one to be used for the Crestron protocol to integrate with my smart home system. So let's go and take a look at the hardware we'll be using for this, because I've got quite an interesting cheap solution, which is quite cool. So let's go over to the table and take a look at the hardware. Okay, so now let's talk about how we're going to do this. As I mentioned, Texecom sell the COM IP and COM Wi-Fi modules, which would be suitable for this, but they are also quite expensive. I think a COM IP is about £150 or something. Additionally, those only connect to a single COM port, so I suspect I might have the same issue I was experiencing in testing, where if I was trying to use Crestron and Wintex over the same port at the same time, I might have issues. Not quite sure on that, but I found a much cheaper option, and it's this. So this is from a whole classification of device, which you kind of regard as like a serial port server device. They're available in a lot of different versions. Essentially what they are cheap little devices. They only cost £10 to £20, if that. And what they do is they take a serial port and serve it over the network. You can get these for all different types of serial ports. You get them for RS-232, you can get them for RS-485. This one's designed for a TTL UART serial port. You can get them in this kind of form here, which is where it's more like a sort of module that would go into a PCB. Or you can get ones in full metal cases with external power bricks that you could mount to a wall and plug in with a DB9 serial cable. There's a huge range of these devices. But this is the one I've gone for here, for a couple of particular reasons. So if you look on the back, we can see a model number. It's, well, not really a model number, it's more of a model. It's from Waveshare, and the model number they give it is 2-channel UART to Ethernet. And that's what this is, basically. It's 2 UART ports to Ethernet. I've put links to all this in the description, but if you look on the top, you can see it's based around literally a single chip solution. There it is there. And the model number of that chip is a CH9121. That's it there. And yeah, this is a TTL serial 2-port to Ethernet adapter. So essentially what this means is you can connect 2 different TTL serial ports into the bottom of this, and it'll expose them on the network as 2 different TCP ports. So it'll listen on 2 different TCP ports. One port will connect to one of the serial ports, one port will connect to the other serial port. There's another way this can work as well. It can work as a client, so instead of you connecting to a port that's listening on this would connect out to a port on an external server and transfer the data that way. You can kind of do it either way. We'll take a brief look at the configuration of this later. But yeah, that's it there. It has 2 serial ports in this header on the bottom and an Ethernet port on the back. So that's what we're going to be using. So as you can see, this is a slightly interestingly shaped device. It's got these connectors on the bottom here and these 2 weird pins that just stick out at the front. That's because this is designed to mount on a PCB. The idea being, if you've built some sort of project around a microcontroller or whatever you're doing, and you want to give it network connectivity, rather than having to implement a whole network stack into your hardware, you can instead just have a serial port or a TTL serial port on your microcontroller, solder this module to your board, and give it network connectivity. So it's not really designed to mount inside an alarm panel like we're doing here, but we'll make it work. Essentially all you've got is on the bottom of the module, you've got these connectors here, which have all the connections you need. So they've got 5 volts at the top to power it. You can also use 3.3 volts instead, but in this case we're using 5 volts because that's the logic level of the serial ports. Ground, reset, transmit and receive. And the transmit and receive there's 2 different ports. You can see there's transmit 2, receive 2, and transmit 1 and receive 1. There's various reset type pins as well. But yep, down here you've got the 5 volts, ground, and transmit and receive for the 2 COM ports. So all we need to connect this up to the alarm panel is some sort of wiring harness, which I've already made. So here we have it. Now it's not the prettiest thing in the world, but it does work. So as you can see, we've got this big long ribbon cable, and on one end we've got a connector that will go directly into the bottom of this module. So it's just this connector here. It's a DuPont connector, I think that would be called, and it's just a connector like that that'll just fit directly into the bottom of this. So that'll just plug in that way around like that. So that connects in there, and that's now the module connector, this wiring harness. I bought these connectors myself and just crimped them on. They're actually really easy to do, and the connectors and crimp tools are very inexpensive. So that connects onto the module at that end. And at the other end, we have these two connectors that go to the alarm panel. Now, these connectors aren't officially the correct type for the alarm panel. I think the alarm panel uses Molex KK connectors, the same type of connector you use in a PC fan header. These do fit. They're the same sort of pin diameter, but the pins on the alarm panel are a bit too long for these. So when you plug them in, the pins don't quite go in all the way. It works completely fine, but just don't force them all the way in because you'll end up damaging the connector if you try and do that. I could replace these with correct connectors at some point, but these are what I had, and they'll work fine. So on this end of the ribbon cable, we've got two connectors. The top one has transmit, receive, ground, and 12 volts coming from the alarm panel. And the second connector just has transmit, receive, and ground. So this is the first COM port and power, and this is the second COM port. And these come down here and connect into the serial port server module. So that's what I've made there. However, as I mentioned, the alarm panel outputs 12 volts, but this requires 5 volts to operate. So I couldn't just connect the 12 volts in the panel into this because I'd probably blow it up. So that's where these two connectors here come in. What I've done is 12 volts from the panel comes down here out this red connector, red and black connector, and then we want to feed 5 volts into this white and black connector that feeds 5 volts to the console server. So for that, we're going to use this little module here. This is just a cheap little DC to DC converter. So it's 12 volts in, or 8 to 22 volts in, 5 volts out. And that's all I've got here. So we've got 5 volts in on the red and black, and then 12 volts in on the red and black, and 5 volts out on the yellow and black. So I've set this up here, so all I need to do is plug that into there, plug that into there, if we get it the correct way around, like that. And that would now be ready to go into the panel. All I would need to do is plug these into the COM ports on the panel, stash this away inside the panel somewhere, connect this to an Ethernet connection, and set it all up. I'm all sure a COM IP would be a much neater solution. It would mount neatly inside the panel and plug in with a perfectly sized cable and wouldn't need this external power supply. Given this whole setup probably costs about £25, if that, versus 150 odd for a COM IP, this is the way I'm going to go. Now, obviously, if you're a professional alarm installer, go for the proper Texecom module. Don't go and give customers this kind of bodgy setup. But for my own setup for now, this works absolutely brilliantly. And as a slight disclaimer, this is already something I already had set up, and I've had it running for a good year or two now. I've taken it out to make this video on it, so this has definitely been perfectly reliable. So what we'll now do is we'll go away and get this installed inside the panel, and then we'll take a look at how we're going to set it up and integrate it with a smart home system. And here we go, that's all now installed. So as you can see down in the corner there, I've now installed the module. So I've just kind of hidden it below the power supply. It's not the best place for it, but it's really the best place I could kind of really fit it reasonably. So it's hidden in there. The cables then snake up there and connect to the two COM ports. So you can see that connected up to the COM ports up there. And then just to the right of the power supply, tucked in here, we have the power supply module. So that's tucked in there out of the way. So that's all hidden in there. You can see the power lights lit up, as are the two channel lights. So that's indicating that there's a connection on both of those serial ports because the smart home system's already set up to connect to that. So everything's now connected automatically. So it's actually now sitting there working. You can see there's network activity on the Ethernet port as well. The Ethernet cable just comes in behind the panel, up, round, runs along the top there out the panel, and then just plugs into that network jack up there, which used to be used for a camera, but I'm going to be changing the CCTV setup. You'll see that in a future video. So that port's been freed up, so I can now just plugged into there. So that connects into the network. So yep, that's module all now installed inside the panel, and it's working. So what we'll now do is we'll quickly take a look at how we configure this within the Texecom settings, then we'll take a look at how we use it. Okay, so now that's all installed, let's take a look at how we configure these COM ports. So I've logged into the alarm as engineer mode, so we can now go to UDL/Digi options, into here, we can then go to 8, which is COM port setup, press that, and this is where we can set up each of the COM ports. So we've got onboard Digicom, COM port 1, COM port 2, COM port 3, and expansion port. So the two COM ports we're using are COM port 1 and COM port 2. I don't think this panel has COM port 3, or I think it's maybe part of the wireless system, I'm not sure. So yeah, we've just got COM port 1 and 2, so these need to be configured. So the first COM port I'm going to be using for Wintex. So this will be where I connect from the Wintex Windows application to configure the panel. For that, you just want the COM port set to be nothing fitted. There's a few other options in here, so you can go into this and you can go through and see all the types of things you can connect. The COM300, 2400, their modems, an ISDN module, COM IP, modem unit, all these different modules you can connect. But if you just leave it on nothing fitted, that's fine for connecting Wintex over either a USB cable or this setup here. Now, you may be tempted to set COM IP here, which I initially did try because I thought, well, this is basically a COM IP module, but this doesn't work. And that's because even though the COM IP module essentially is a TTL serial server, it does have some extra configuration. So I think the panel can send like configuration data to the COM IP because you set its IP address in the panel, and then the panel sends the configuration across. And I think there's maybe some sort of heartbeat as well, where it wants to configure, it wants to be able to monitor the COM IP module's health. So if you set COM IP module here, it won't work and you'll get errors. And I think that's maybe why it's beeping right now, because I've just picked COM IP module, I'm not sure. So yeah, you don't want to pick COM IP module here. You just want it to set that one to nothing fitted, because yeah, I set the COM IP module and that's why it's making those noises. I think it's unhappy because it's not seeing that heartbeat with the COM IP module it would expect. So COM port 1 we're setting to nothing fitted, and this is the COM port we'll be using just to configure the system over Wintex. Then COM port 2, we're setting up for the Crestron system. So again, you can go into this, you can pick all the different systems that are available on this. In this case, we're going to use Crestron system because this is probably the easiest kind of protocol that you can understand. It's a there's enough documentation on it. It's relatively easy to understand and kind of figure out. So yeah, we're going to be using the Crestron system because that's pretty easy to use. And we'll take a look at that in a minute. So with both of those set up there, that's COM ports configured. Now, I think there's some additional stuff in here you might need to do around setting baud rates. Both of mine are set to 19200, I think, baud, but I don't quite know what the defaults are, so you might need to try and find settings in here to change baud rates. I'm not 100% sure, but that's COM ports now set up. So with them set up there, what we can now do is log out of all of this, and then we can go and take a look at the laptop and see how we can use this setup. Okay, so now we're on a computer, so let's take a look at how we set this up. So the first thing we'll need to do is set up the module. Now, to configure this, it's a little bit weird. The main way of doing it is using this Windows software called Net Module Config. And if we open this, it's a bit weird, dodgy looking. It's fine, it does work. You can download this from the Wavelink website. So if you find the Wavelink product page for this, I'll put a link in the description if I remember. If not, chase me in the comments and I'll put a link in. You can download this software from there. I think you can also configure it over just a general serial connection and give it certain commands and like set random bytes to certain things to set all the parameters, but the Windows software is just a lot easier. And realistically, once you've set it up once, it's set up forever. So you open the software here, and then it's just weird, like it asks you to pick an adapter where it wants my Bluetooth device, and these are my network interface on my machine. Turns out you don't need to set this at all. If you go down to here and click search, it will search my network and somehow magically finds the device, so that's it there. This is already obviously set up already, but I'll show you how I set it up. Then when you double click that, it loads the config in, so you can see currently I'm using DHCP, but you could set a static IP address if you wanted to. Then over here you have your two ports, so you have port 1 and port 2. These are the two COM ports on the back of the device. So on my system, port 1 is connected to COM 1 on the Texecom, and port 2 is connected to COM 2 on the Texecom. Port 1 is for Wintex, port 2 is for Crestron. And in here you can see you can set various settings. So basically the settings are the same on both of them. I'm setting a local port, so this is the port that this device will listen on. So for one of the COM ports, it'll listen on port 2000, the other one will listen on port 3000. You could set any sort of ports here you want. Then we're setting the baud rate, which is 19200, which is the same on both, 8 data bits and 2 stop bits. Now, some places say 1 stop bit, some places say 2 stop bits. I found in my testing that if I set it to 1 stop bit, I'd occasionally get slightly corrupted Crestron messages with like an extra byte at the start or at the end, and some of the messages would come in a bit funny. We're setting it to 2 stop bits, works perfectly fine, but you may need to try a couple of options here. But yeah, this is how I set this up. And with all that set up, you can just simply save the config and that should work. The other thing to just quickly demonstrate here is the mode. So this is set up as a TCP server, so it'll listen on port 2000 for connections. You can essentially telnet in, and it'll basically drop you onto that serial port. You can also do a UDP server, so it's that same thing. It'll listen on a port, but it uses UDP, or you can do it as a client. So if you set this up as a client, it'll enable different fields here. So instead of listening on port 2000, it will connect to this IP on this port and connect that way. So you could do that instead. Instead of having this connecting into this device, you could have this device connect out to another service. So you can kind of configure it how you want. This is what we're doing here. We're listening on 2 different ports, and each port is mapped to one of the COM ports. So now we can take a look at this working. Okay, so the module now set up. Let's see how we can control the alarm over this, because this is really cool. So, as I mentioned, we're using the Crestron protocol for this, and if you dig around online, you'll find some documentation. It's not something that Texecom officially published to the public, so you won't find a nice PDF that just details the entire thing. However, a lot of people have made their own little integrations for different systems using the Crestron protocol. So if you look around, especially on places like GitHub, you'll find other people's documentation and code that kind of covers everything you need to know. For example, we have a document here that kind of gives a huge amount of detail. It's on GitHub. It's part of a Homebridge integration that someone's built. And as you can see, it shows a lot of the status updates you're going to get. So with the Crestron system, you can either send commands to the system, or it will just automatically send status updates to the serial port as they happen. For example, if you've got a zone update, you'll get Z, the zone ID, and then 1 when the zone's active, and then 0 in the end when the zone's is deactivated. These three numbers here represent the zone number. Then you'll get area events, so if an area is being armed, if an area is actually armed, an area is being disarmed, an area's been triggered, the alarm's gone off, you'll get L and then the area number. If the area entry is triggered, so someone comes in the door and it starts counting down waiting for the code to be put in, you'll get E. So you can get all these status updates as they happen. Again, when the user logs into the panel, you'll get U. You can then issue a couple of commands to the panel as well. So if you issue A status to the panel, that shows you the armed status of each area. So you can see if the system's armed or disarmed. And if you issue L status, it'll show you what's currently being displayed on the LCD keypad. There's one more command that isn't shown on this page here, and it is the key command. So if you send the word key followed by a number or another button, another character that represents a key on the keypad, you can send keypad commands to the system. So as you can imagine with this, you can basically do anything you could do to the system with the keypad. You can see what the keypad screen says, and you can send keypad events. So you basically have full control over the system with enough scripting. So it's really pretty powerful. So let's take a look at this working. So we'll get the browser out here, and if we come over here, we've got PuTTY, so just standard telnet client, and we're going to telnet to the IP address of the module on port 3000, which is the Crestron protocol's COM port. So we press open, we're now connected. So I'll bring that back over here, and here we are in the system with PuTTY. So we can now start issuing some commands. So right now, there's nothing happening. We're not seeing anything, it's just sitting as a blank console. But what I'll do now is I'll run through to the next room and I'll wave at a PIR and trigger a zone update. And you'll see that update in this console here. And there you go, that worked. So we see the zone being triggered when I first walked into the room, and when I left the room, the zone became untriggered again. So that you could use that to easily detect PIRs and motion sensors and doors and everything being triggered. So you could integrate this into your smart home system, turn lights on and off automatically, and do really anything you wanted with that. But of course there's more. So what I'll now do is I'll run over to the keypad, I'll log into the system, and then I'll arm the system, and we'll see what we get then. And there you go. So what you saw there is U was when I logged into the system and put my code in, X was when the arming started, it started the countdown, and then A was saying the system's now armed. So what I'll now do is I'll go and open the front door, which will start a countdown, and then I'll put the code into the system and disarm it, and we'll see what happens. And there you go. With that, what we saw was E was the entry being triggered, so that's when I opened the door. We can see a zone being triggered, and then deactivated again. That was the front door contact, so that's the door opens up, the door contact becomes active, door contact becomes deactivated, that's the word. Then U, which is me logging into the system again, and then the system is disarmed when I disarmed it. So as you can see there, you can straight away just read these events from the serial port directly, and basically have a good idea of what the system's doing. The final test I want to demonstrate here is what happens if the alarm is triggered. So I'm going to be very quick with this because I've got it set up that if I do a part arm and trigger the system, I'll have 30 seconds to turn the alarm off before the outside siren goes off, which I'd rather not do and annoy my neighbours. So I'm going to very quickly do a part arm, set the alarm off, and then quickly disarm it within 30 seconds before the outside siren goes off. So keep an eye on the status updates and you'll see what happens. So there we go. As we can see, that was me logging in, the arm countdown timer starting, the system being armed. That's the alarm state. So L means that I've triggered the alarm. That was triggered at the same time as this zone, so I set off that zone, the alarm was triggered, I then logged into the system and disarmed it. So all I would need to do now is if I wanted to build a system that would alert me when the alarm's gone off, all I need to do is build something that connects to this, looks for these L messages, and if it sees one of those, it sends me a notification. It's dead simple. Okay, so it's all well and good being able to get status updates out of the system, but as I mentioned, you can also issue commands to the system to control it. So here we've got another console here, again just connected to the same COM port on the Crestron protocol, and we can issue some commands. So if we issue a status, that gives the arm status of each area. So we have 4 areas, each of these are disarmed, so N basically indicates disarmed for all the areas. The other command we can issue is L status. And this basically shows what's being displayed on the LCD screen. So currently nothing very interesting, just the time, but if the system was doing something or you're controlling it, this would show it's on the LCD. So how do we control it? Well, this is where we use the key command. So key, and then a key we want to press on the keypad, and that'll press it. So what I've done for this demo is I've changed my code to 1234. Obviously I have a more secure code, but I'm not going to put that on YouTube. So we can type my code in and arm the system from this console. So key 1, key 2, key 3, key 4. L status, you can see it says the user's logged in with that there. L status, do I want to arm system? Key N because I want to do a part arm. L status, do you want to part arm system? Key Y for yes. L status, do you want doors only? Yes. Key Y. We're now starting the countdown to arm the system. That's what the X means. Give it a few seconds, the system will arm. Just need to wait for that. There we go, I heard the alarm beep. A0011, the system's now armed. So now if I issue a status, we can now see we have an armed area. So as you can see there, it's YNNN because area A is armed. So you could easily use this to also check this arm status. You don't have to catch these status messages as they come in. You can easily go and connect to the console, issue commands like a status periodically, and read the result. Likewise at this point, if we did L status, you'd see the LCD is saying part armed, and it'll toggle between 2 things. There we go. Okay, I've typed a lot of junk in here, but the LCD is kind of switching between 2 different things at the moment. It's saying part armed with a time, and then saying doors only, which is the name of the part arm. So I basically issued a bunch of L status commands to catch when the screen's changed over to the other thing because it's flipping between the 2. We've got a zone trigger there. I think I just moved and that triggered a PIR. This is a part arm, so that won't set off the system, thankfully. But yeah, that's now worked. So we can go L status, we can see the system is armed. And what we can now do is disarm it. So to disarm it, again, just enter the code. So key 1, key 2, key 3, key 4. User logged in, L status. Do you want to disarm system? Key Y for yes. Disarmed. And then A status. All ends, the system's now disarmed. So that shows from this console, with just those simple commands there, you can not only read the status of the system and get actions live as they happen, but you can also fully control the system. So if you want your smart home system to be able to set your alarm or arm your alarm remotely through some sort of script, well, you can do that. So then here we have my Node-RED set up. Now, this flow is a bit of a bodge, it's all kind of just hacked together, but it does work. So what we're doing here is we take the messages coming in, we connect to the system, receive the messages, do some JavaScript just to do some basic parsing of them. We then have a thing here where we filter on message type, basically based on the first character. So is it an arm, disarm, arm start, I think that is, or a user login, all these kind of things. And then we use that to store the arm state, and then based on the arm state changing, we set home and away in the smart home system, which is also linked into Home Assistant. So this will do things like disable my heating, so when I go away, my heating will turn off, when I come back home, the heating will turn on. It also triggers some switches that we'll take a look at in a second that turns the cameras on and off. We'll talk about that later on in this video. And yeah, this all works. However, I also wanted to be able to poll the system just to make sure I never miss a message. I don't want some little network interruption or server restart or something missing out on an event. Because, say for example, if I leave home and I arm the system, if I miss that initial arm event, the cameras wouldn't turn on. Or if the system was triggered, someone broke in and the alarm went off, and for some reason a little network interruption or whatever meant I missed that message that indicated that the alarm had gone off, I would never receive a message for that. So what I do is I have this little bit here that periodically every second polls the system. It's maybe a bit too frequent, I don't know how frequently you're meant to poll this. But all it does is it polls the system. And there's a little bit of JavaScript here that alternately sends L status and A status. And then we can parse the output. So we can see here that's the output coming in here. So we see NNNN, so it's seeing the system's disarmed constantly. And also we're seeing what's on the LCD. So if the system's armed, we'd immediately be able to see in these polling messages that the system's armed. If the system was triggered, I'd be able to read off the screen saying that an alarm's gone off and all that kind of stuff. So the polling is just like an extra backup. So yeah, that's kind of my Node-RED flow. Now, I know lots of people are probably going to end up commenting, wanting my Node-RED flows, wanting me to export it and give them a copy of it. People tend to do this in a lot of my videos where I show Node-RED, but the difficulty with that is that this is a completely custom system for my own environment. I could package this up and send it to people, but realistically there's no magic here. And if you understand Node-RED in detail, you'd be able to build this. And if you didn't understand Node-RED in detail, you wouldn't really be able to use this for anything. So there isn't really any point in me packaging this up because it's so proprietary to my setup. But that's kind of what I do. I receive status updates as and when they're sent out, and I poll the system for updates on a sort of frequent basis. So that's a look at how I've integrated it using the Crestron system. But as I mentioned, I've also set up that second COM port so I can use Wintex to configure the alarm. So that's relatively easy to do. So obviously the COM port's all configured as we demonstrated previously. So we'll just open up the file which indicates that my setup here. You'd have a file configuration for each alarm panel you work on. I obviously only have the one. We can edit account, and then here it shows all the details. So we can have all the panels set up. We have a UDL password. This is something you need to set on the keypad, and it's a password that you need to issue to be able to configure the system remotely. So that UDL password set there, and it's defined in the account settings. And then down in this weirdly out of the way, hard to find box here is where you set up the network connection details. So we have the IP address of the device and the ports. This is port 2000 this time. 3000 is Crestron. 2000 is that COM port that's set to not configured. So that's set there. Then all we need to do is hit connect via network, press that. Bottom left, we'll see it'll start connecting. It says online ready, we're now connected. If we press receive panel programming data, that'll download all the configuration from the panel. Your system holds a copy of the configuration and then you can update it from the panel. So you can change the configuration offline and upload changes, but this will download the latest changes from the panel. It's working, so we're able to talk to the panel. So I can come into here, I can go into, for example, my zones. I can see all my zones and how they're all set up. I can configure all that. I can go into areas. I can change all my areas and how all the power arms work, all the timers, all this kind of stuff. I can go to keypad, so I can pull this up and I can view a virtual keypad and essentially control the system through this rather than using the Crestron remote keypad. System alerts just because I've set the system off and I've not reset it after setting off an alarm, so I also need to change that there. But yeah, this works. So as you can see, I can also now configure the system over Wintex, and I don't need any USB cables plugging anything into the panel. Any device on my network I can connect from Wintex and configure the alarm system. It works really well. So yeah, that's the whole setup. But there's one more thing I want to talk about in terms of this network setting and configuration, all this kind of stuff, before we go on and take a look at how I'm making the cameras switch on and off. And that is security. As you can see here, there's no real authentication. Well, there sort of is, but I wouldn't really trust it too much. When it comes to the Crestron protocol, sure, there isn't a magical command that would just disarm the system. You don't just type disarm and it disarms it. You have to type in a code. So you have to type in key and then the code and then do something like that. So you couldn't just magically disarm the system over the network. However, you do essentially have a port listening on a network there that you can issue commands to the alarm system directly. And I don't think it would be that hard realistically to very slowly brute force a user code. Like, they're only 4 digits. If you just issue a new code very slowly into the system and wait for it to let you log in, you could quite easily brute force a user code over this. I don't think there's any sort of rate limiting. There might be, but I don't know. So I maybe wouldn't want to let this sort of sit listening on an untrusted network. Likewise with Wintex, you do have that UDL password, so you can't just straight away connect into the system. You do need the UDL password. However, again, I don't know what there is in terms of rate limiting on that. It may be something you could easily brute force. So with this sort of hardware setup here, you are just literally going to listen on a TCP port on the network. There isn't any sort of authentication and there isn't any sort of firewall. Now, I think this is the same sort of situation you'd have with a COM IP or a COM Wi-Fi. You'd have the same sort of thing. So if you're setting this up on a network, I would strongly recommend making sure this is kept on an isolated network on its own VLAN and firewalled off. Now, you'll notice if you know my network, this is actually on my main LAN right now. Don't do as I say, not as I do. This does need moved onto its own VLAN. I've just not done it because I've been testing this and setting it up and I've not had time to set up a dedicated VLAN for it. But I would strongly recommend making sure this is kept on a dedicated, isolated network where it can only be accessed by trusted devices through a firewall. If that's too much, what you might want to do is, instead of using something like this and using one of these dedicated modules, instead what you can do is use something like a Raspberry Pi with some USB to TTL serial cables. And with that, what you can do is on the Raspberry Pi, you can run software such as SER2NET, so SER2NET. This is it here. And essentially, it's software you can run on Linux to serve a serial port over the network. Dead easy to set up, there's lots of documentation online, and this would basically do the exact same thing I'm doing with that hardware module. However, the benefit here would be is because it's running on Linux on a Raspberry Pi, you could easily set up a firewall on that Raspberry Pi itself to restrict what IP addresses and devices can connect to it. So yeah, if you've got a network like mine where you've got a firewall, you can easily drop in place, isolate this little module onto its own VLAN. Using these little modules is absolutely fine. But if you're wanting to drop this onto an untrusted network, I'd maybe consider something like this instead on a Raspberry Pi with a TTL to USB serial cable, just because that would allow you to have a firewall there, which might be better to have. But yeah, just bear in mind the security here. You don't really have any kind of authentication here, and I don't think it'd be too hard to very slowly over time brute force a user code. So yeah, just always be mindful of network security, these kinds of things. So now let's talk about how I'm using this integration. One of the things I mentioned I'm doing is I'm using this to turn my heating on and off. So when I go away from home, it turns the heating off. And when I come back home, it turns the heating back on. It just means that I can't go away for any extended period of time and forget to turn the heating off. That's pretty simple. It just uses the Nest API, and you can just really use whatever your thermostat supports to turn it on and off. That's not that exciting. But the other thing I've mentioned is that I'm using this to turn my cameras on and off. So let me explain. If you aren't already aware, I have a Unify Protect CCTV set up. I'll actually be doing some interesting CCTV upgrades coming soon, so stay tuned for that. But as of right now, I've got 3 Unify cameras recording to CloudKey Gen 2 Plus. But these are all inside, because I live in a flat, I've not really got any outdoor space, but I just like having some sort of cameras just to check in on the place. Just for when I'm, say, away on holiday or if I'm travelling, because I do travel quite a bit, just so I can quickly check and just check everything's okay. I also occasionally find myself dog sitting, for example, and if I have to nip out and leave the dog, I can just keep an eye on the dog. Things like that. So it's nice having these cameras. But I don't like having the cameras permanently recording me. Now, I know it sounds completely stupid and it's a bit irrational because I'm the only person that can see the footage that's recorded on this system, but I just don't want to be sitting permanently recorded. Especially if I've got guests over, I don't want my guests being recorded. If I have, say, guests sleeping on the couch, there's a camera in the living room, I don't want that camera recording them on the couch, for example. I just don't really want that. So I want a system where when I'm at home, the cameras are switched off, and when I leave home and arm the alarm system, the cameras turn on. And that's what I've built here. Now, the simplest solution would just be to have some sort of integration in the firewall that when the alarm is triggered, it adjusts the firewall rule that enables or disables the cameras. But in my mind, there's no sort of real substitute for just physically powering the cameras off. That way they are completely turned off. I can see that they're off because the IR LEDs will just not light up. It's very obvious. I can easily tell that the camera is turned off. And I'd much rather that than some sort of firewall rule where the system turning the firewall rule on and off could fail and get stuck and it stays recording and I don't realise for ages. With this system, it's quite clear. So how am I doing that? Well, this is where I finally reveal the purpose of that tiny little TP-Link switch that sits up the top there. Because every time I do a network tour video, loads of people ask about that little switch. And every time that they've commented, I've basically ignored the comment because I know I'm going to reveal it in this video and I've put this video off way too long. So yeah, that's what I'm using this for. So up here we have this little TP-Link unmanaged switch. It's a tiny little 10100 switch. It's a super cheap little thing. And it's a little 10100 PoE switch. It's one of those little 5-port TP-Link things that cost like £30 on Amazon. It's a very inexpensive little thing. That uplinks into my main switch, and then these two cables go off to cameras. But then how do we power this switch? Well, the reason I went for this switch in particular is because the power brick is actually a separate power brick on a cable. It's not just a wall wart that just plugs straight in. It comes into this power brick and then comes out on a cloverleaf IEC connection. So this is the power brick for that switch. And then as you can see in line between the plug and the power brick, we have this little sawn-off switch. Now, the reason I'm needing to do it this way rather than using a smart plug is because I've got this PDU here and there's no way I could fit a sort of smart plug and power brick into this. That would be way too deep. So instead I've done it this way, where we have this sawn-off, and that switches power to that network switch. So when I arm the alarm system, the on-off switch is on, turns that switch on, the cameras turn on, and when I disarm the alarm system, it all turns off again. Separately, I have a little Wi-Fi camera. It's a Unify G3 Micro or something. It's a Wi-Fi camera. So that has its own power supply, and that's just plugged into a smart plug. So that's plugged into a smart plug that, again, is controlled by the smart home system. When the alarm's armed, the smart plug turns on. When the alarm's disarmed, the smart plug turns off. It's that simple. So let's take a look at this working. So we've got a little switch up there. I'm going to arm the alarm, and hopefully you'll be able to just about make out that the switch will turn itself on, and then the cameras will start up. So let's zoom in on that switch, and then arm the alarm system. So we'll just get this on off up so you can see that as well, because that's got a little light that I think will come on as well when the switch turns on, just in case you can't quite make the switch out. So we'll leave that there in a place you can hopefully see the LEDs on it. Just leave that there. And now let's arm the alarms. So I'll just do a power arm again, set that. You can now hear the alarms arming. And once that arms, all that the switch and everything will turn on. Turn the lights off just to make it easier to see. There we go. So you can now see that the little TP-Link switch is now lit up at the top right. It's not that easy to make out, but hopefully you can just about make out that that's now lit up and connecting to the network, and the cameras are turning on. And you can see the red lights come on and on off, indicating it's also giving out power. So, yep, that's now power the cameras on. Okay, so now let's take a look at disarming the system. So as before, we have the red light on the on off that indicates that it's powering the switch on. And if you look up in the top right, you can just about make out that the switch is operational and it's blinking away because the cameras are on and sending traffic to the NVR. Then if we bring my phone in, we can see, if you look at my phone, we have a live video feed from the camera. So that's me hiding behind there, hello. And that's now working, so we can see the cameras getting a live video feed. So what I'll now do is I'll disarm the alarm system, if I can get around to it, and then we'll hopefully see the video feed freeze. So that's the alarm there, that's the video feed coming in there. Let's disarm the alarm. Like that. And then if I press tick, that's now turned off, the camera's now lost power, and you'll see that I've frozen. So if I come around here, I've completely frozen, looking a bit gormless in the corner there, completely working fine. I'm now waving at the camera, you know, nothing, I'm not moving, the video feed is completely frozen, so that's worked. Then if you look behind here, you can see the red light has gone off on the on off, and the switch is turned off in the top right as well. And if you look back at the camera there, you can see it's now saying camera lost power. So yeah, that's worked. So that's killed the camera when I've disarmed the alarm. This system works really, really well. So there we go. That's a look at how I've integrated my Texecom Premier Elite Burglar alarm system with my Node-RED smart home system. And it works really well. As I mentioned earlier, I've actually had the system in use for a good couple of years now, and I'm just finally making a video on it now, and it's worked absolutely brilliantly. And it just goes to show the actual power of actually having a simpler device like this that isn't smart, it doesn't have built-in Wi-Fi cloud connectivity and all that kind of stuff. It's a relatively dumb system, but just having that good serial connectivity that just lets you get in there and just access the raw data and connect it onto really anything you want just gives a huge amount of power. If I'd bought some sort of Ring or Simply Safe or Verisure or whatever other brand of smart alarm system they're doing nowadays, I probably wouldn't have this power. I'd have to use some sort of API and poll it, and that would be if there was an API. With this, there isn't even any hackery. It's just literally a serial port. So yeah, it actually works really, really well. So yeah, it's been quite a fun project. It's been a long time coming, me making this video, because I've been sitting on this project for so long and never getting around to finishing it. But hopefully people found this interesting or maybe useful if you've got a Texecom alarm and you want to integrate it with your smart home system. But all that's left now is say thank you very much for watching, and stay tuned because you've seen my CCTV switching on and off in this video, but soon I'll be doing another CCTV upgrade, so stay tuned for that as well. But yep, all that's left to say now is thank you very much for watching.